Okay, hello everyone, and welcome to the AI 3.0 ecosystem panel number 4, where we'll be lifting the lid on decentralized AI data storage and availability via decentralized physical infrastructure networks, commonly known as DePINs. I'm Jim Counter, the head of community at Autonomous, and it's a pleasure to be your host today. I'm joined by leaders and innovators shaping the intersection of Web3, AI, and decentralized infrastructure. I have Chris from Impossible Cloud Network, a decentralized cloud provider for delivering enterprise-grade data storage and retrieval. I'm also joined by Zeus, co-founder of Multiple Network, specializing in secure, accelerated, decentralized bandwidth solutions optimized for AI data transmission. Today, we'll explore how DePIN is transforming data storage and availability, enhancing decentralized AI capabilities, and setting new standards in the AI 3.0 landscape. So let's start by learning more about our panelists and their inspiring journeys. Could each of you briefly introduce yourselves, tell us about your path into Web3, and share what inspired you to work on your current project? Chris, can I pick you first, if that's okay?
Yeah, of course. Yeah, sure. I don't know if I have the most inspiring journey, but yeah, I've been in the crypto space about 7, 8 years. Been deep in the tech side, so I've worked on layer one blockchains, smart contracts, protocols, economic, mechanisms, everything. And I feel like maybe I'm one of the cypherpunks. I'm kind of here for the same reason that everybody's in the Web3 space, I think. And it's just to disrupt the power dynamics that we know today. And I think the project that we have at ICN is one of those key infrastructure dependencies that we have on our daily lives. I've worked on previous projects in finance, which I think was to do a similar thing, kind of change the way that power structures work to better enable and empower the little man. And I've also worked on identity systems. That was my previous project called Violet. So a lot of protocol work, and I'm at ICN now working as a product lead.
Thanks, Chris. We've just been joined by Charles, sorry. Charles, can I see if I can add you to the stage? Charles, are you there? Hey, Charles. So we have Charles from Swan Chain. I think he's having some technical issues. We'll see if he can come back in a minute. But sorry, Zeus, I've ruined the flow now, of course. Zeus, do you want to give us a breakdown of introduce yourself and tell us about your journey, please?
Yeah, sure thing. I'm Singaporean and Canadian, calling in from Hong Kong. Evening, 10 p.m. right here. So started in Web3, just buying Bitcoin 2017, and actually helped fuel my MBA costs. Made 10x when I sold it in 2019. Did my MBA in the UK in Oxford. After Oxford, when I wanted to start building something, I started with something that I'm a bit more familiar with. In Singapore, I did some communications work for one of the warships. So that's how I'm familiar with communications technology, part of which I'm applying in my project, Multiple Network. So we use SD-WAN, software-defined wide area network. Happy to explain a little more later.
Thanks, guys. I'm definitely picking up there's a kind of a British vibe going on here. It feels like everyone's probably got links. I picked up on your accent now, Chris. And Zeus has obviously spent time over here. I'm down in Kent in the UK. So yeah, that's a great, Zeus has just teed us up very nicely. So it's time, yeah. Chris, if you could go first, just give us a rundown on your project's core mission, what makes it unique in the Web3 AI 3.0 landscape, which specific problems you're solving, and what do you believe sets your technology apart, please?
Yeah, sure. I mean, you've got a good ear. I'm actually based in London. I'm a Londoner, so not far from you, actually. But yeah, ICN. So what are we doing at ICN? I think there's a lot of DePIN projects out there. One of the things that we've witnessed in the space is that the modern internet today isn't really Web3 enabled. A lot of the projects, even in Web3 right now, when you look at all these layer ones, where are they running ultimately behind the scenes? It's on AWS, which is centralized cloud. It's Web2 cloud. And so a lot of the things that people try to build away from, they end up having to kind of accept the risks of, because they only run on an internet infrastructure that is kind of archaic. ICN wants to change that. We believe that if Web3 and kind of the wider crypto native ecosystem wants to grow, wants to truly expand, it deserves a native infrastructure to build on. And that native infrastructure needs to deliver as a first-class citizen the kind of the core tenets of Web3. So, trustlessness, sovereignty, and we believe that digital sovereignty is a big kind of value for us in terms of when you think about where does data lie, how does data flow through the internet, and how much of these digital ecosystems we rely on today, how much of them are really owned by, like, let's say, these 5 big cloud players, right? Google, Amazon, Microsoft, Ali Cloud. There's only a few companies that are really running 99% of the internet. And so ICN's mission is to change that. We want to create a new layer to support the growing Web3 ecosystem. And we can only really build out into the future that we want to see if we're building it on dynamic and flexible Web3 enabled internet infrastructure. And we do this through kind of a separation of layers that are traditionally very centralized. So when you look at traditional cloud, down from the hardware infrastructure all the way to the software service stack, it's kind of completely vertically owned. And Amazon is the perfect example for this. They own the entire stack, right? They even own the wires, the cabling between data centers. They own the data center, they own the hardware in them, all the way up to owning how they deliver, like, let's say, an object storage service to you. ICN wants to decentralize all of that, and there are many roles in that, and so we have to kind of delaminate and split them into layers. So our first layer is at the hardware layer. We run a decentralized network of hardware nodes that provide capabilities as a kind of globally available resource pool. So the idea is that anyone, anywhere can access this hardware pool of any kind of hardware class. This can be storage, this can be compute. We've started with storage because we believe that there's gravity in data, so starting there makes the most sense. And we provide that to a software kind of abstraction layer where people can then deploy applications, deploy services on top of that hardware. So depending on what kind of service you run, whether it's a layer 1 protocol, whether it's like an object storage Web 2 kind of thing, we want to enable everything. And our key selling point there also is it's key if Web3 wants to meet adoption to be able to meet the real world where it is. So we want to still enable the legacy Web2 internet whilst enabling the future potential for Web3.
That's certainly some themes there that resonate with our mission at Autonomous, of course. Yeah, it's certainly a concern, isn't it? Decentralization, as you say, the verticalized stack in the hands of very few. Yeah, it's interesting. You see when there's an outage, you see which networks are affected. That could mean that there's a number of like nodes on AWS, but certainly an ambitious mission, Chris. Decentralized AWS. I was researching your project earlier, and that was my top note actually. Thanks very much, Chris. Zeus, same question to you. Give us an insight into your project's core mission. Which problems are you solving?
Mm-hmm. Yeah, it's very good to start from this question, Jim. So we started off trying to solve the problem, which is one of the most common, biggest problems, data transfer speed. So take, for example, right, internet speed. Even as fast as what we have right now, it's never fast enough. Everyone's always hungry for more. And who's our target customer, right? Who really is hungry for more? We're targeting mainly AI companies. The need for data is constant, especially when they're sending data from where they are pulling it, the data source, to where they are training it, the training center. So we accelerate data transmission, especially between these two. Very often it's different sites, right? So take, for example, if it's a sports watch, a Fitbit, right? They're feeding data constantly as we move around, as we go about our day, from all over the world, many different individuals, and they're mobile as well, trained at a core center. So they constantly have to pull, let's say from here in Hong Kong all the way to the west coast of the US. And you have to go through a lot of undersea cables, a very traditional bottleneck in terms of data transfer. So how we plan to overcome it and how we have overcome it is through a few ways, mainly through SD-WAN. I briefly mentioned it just now. What it means what it stands for is software-defined wide area network. So we have a global private network within which we can choose the most intelligent pathway, typically the one with the biggest bandwidth. To create such a network, we need nodes globally. And for nodes, they are replacing the standard servers, a bit like what Chris has shared just now when he took us through the layers. And we welcome anyone to contribute as a node. Right now, any personal computer can turn the computer into a node by downloading our software and choosing the amount of upload and download bandwidth they want to contribute. And from there, they make up points and tokens. There are two other technologies that we use, but I can save it for later.
Okay, thank you, Zeus. Yeah, okay, so I have a little confession to make. I got into Web3 through node running, so this is all super interesting to me. And I do want to hear more about the nitty-gritty on that, Zeus, about how you accelerate bandwidth. Right, I'm going to bring Charles. Charles, are you there? How are you doing?
Yeah, finally, I got online.
Okay, wonderful to see you. So Charles is from Swan Chain, and Charles, just to catch you up, if you could give us like a quick introduction to who you are, and you know a brief intro into your project, the core mission, and the problems that you're trying to solve.
Yeah, actually, like I get into the Web3 industry since 8 years ago. So initially, I was thinking about converting all the GPU miners from Ethereum network to provide computing. So then, like we think like the AI has a bigger potential. It will need a lot of computing power in the future. But back to the 8 years ago, so we decided to get all the computing power from data centers, started contributing to the AI. So what we have been done is we connect lots of data centers, or 100 data centers in the world, building a network and contributing to hosting small models like Llama 3, Stable Diffusion, to provide inference network to different projects who currently running AI agent. So this is what we're doing. And we're also using lots of storage and based on cache layer to process important data. That's why we're very interested in working with autonomous, because we know like you guys is the best in the storage and caching technology. Yeah.
Okay, thanks, Charles. Thanks for that introduction. So yeah, I mean, I can obviously the theme here is that you know, we are trying to harness in a decentralized fashion, you know, in a way that's not owned by a small, you know, or a single entity, a small number of entities, but trying to harness efficiently, you know, the resources that are out there, which is really what DePIN's all about. So yeah, I think it's clear to see the parallels between our projects. Thanks, guys. Okay, so the first question that I'd like to ask specifically is, so the unique benefits or applications. Which do you see for on-chain storage? So not just like you know, storing on an AWS server, for example. So typically, you know, on-chain provides certain, you know, verifiability guarantees. So yeah, what kind of what benefits applications do you see for suitable for on-chain storage? And then when you're storing data on-chain, how do we address data privacy and security? Chris, do you mind going first?
Yeah, sure. Data storage on-chain, I think, is to me at least, it's a bit of an oxymoron, right? Because when you think of blockchains, you don't really have that much capacity, and you don't have that much compute to verify that. And if you try to, you'll spend a lot more time trying to verify every byte. And so I think it's the way we should be using blockchain should maybe be more around verifying data. Storage and storing things, everything on chain, I think it is very difficult. And you see that, right? Because otherwise, if you run a fully kind of, let's say, decentralized L1 just for storing data, the amount of work that you have to do data sampling it or verifying it or replicating it to make sure that censorship isn't a thing. So you don't want data to be stored somewhere to suddenly go offline. That's kind of a lot of the work that you have to do. And I think it focuses more on the verifiability aspect than, let's say, the use cases of it. And I think if you want to focus on verifiability, maybe it's best to find different data structures to make sure that you can prove data exists rather than trying to store everything on a blockchain. But with that said, I think when you think about use cases that need proving, then you need to, let's say, irrefutability. So you want to prove that something happened or not, or if you want to prove, one of the previous projects I worked on is around identity data. You don't want to put those things on chain, but what you do want to do is be able to, let's say, make a zero knowledge proof or prove something about your identity to then give you access to something. And I think these are the kind of use cases that I think we should be seeing more of in the future as we move to a more digital world, but also more on-chain world.
Yeah, okay. So yeah, I take your point there, which is that, you know, if you want to store some data on Ethereum, for example, it's incredibly expensive. I see that Todd's actually popped up in our chat on YouTube. So autonomous, you know, we have our farmers store the chain history in their plots. So we do have that abundance of block space. But I fully agree, Chris, you know, on-chain storage isn't appropriate for every data set. But yeah, the mission that we've been on at Autonomous has not been easy, as Todd says. But yeah, we feel like we're in the ideal position for anyone who does want to store their data on chain and have it verifiable. You know, we're a great place to store it. It's kind of our whole thing. Our consensus runs on it. Zeus, same question to you, please.
Right. So after you have stored data, right, assuming that it's nice and private, there's one more link, accessing the data. So that's where we really come in. We make sure that when you're accessing it, when you're transferring it, it's very private. So first thing that we do is to encrypt it. On top of encrypting it, when we send data, the second piece of technology that I haven't shared is that we split the data up into many different packets, usually as many as 30 different packets. So each node has a piece of your data that doesn't kind of make sense individually. So it's a double protection to ensure privacy. That's the second part. And the third thing is that we delete it right away after sending it. So there's not much of a storage process within our network because privacy is very important. So yeah, I think it's very important. And even at the storage level, if similarly encryption takes place such that only the designated recipient can receive it and decrypt it, it would very much make sense as well and make it more accessible for more than just very specific data sets and use cases.
Thanks, Zeus. So focusing on the security side of things, which is, of course, a really important consideration because everything you put on chain is public. So you're going to need encryption, and you know that's at rest. But while in transit as well, sounds like multiple have got their kind of their infrastructure set up to protect your privacy. Charles, do you mind the same question? So we're just talking about what applications do you see for on-chain data storage and addressing privacy and security of that data?
Yeah, so that is quite interesting because we have been trying it since 4 years ago. So what we noticed that is that was important data. For example, the billing and the transaction data. That's super important. When we're doing the AI and the computing stuff, that was especially when we're doing the task auction engine. So the critical part is about what kind of task it have been performed, what kind of payment you have been made, slashing on or some kind of request, what is the original data source, and also like there was spaces like people say that importance of the transfer the data, right? I give you the data and how you can prove that you are not malicious using it, and also like save the data safely. So that was a lot of technology we needed, and we not just needed it to be like store safe, but we also needed to make sure the data ownership, right? So currently, like we say, like a ChatGPT or something, what happens, like like lots of people are telling us, like when they're using the ChatGPT, one day they shut down their account, But however, the data should belongs to user. I have the conversation with use. I have conversation with this application. Why you give me data? You just shut down my account, but it didn't give me data, right? So AWS, Google, they have some issue, right? I heard like a lot of people say that their account was shut down and only gave them very limited time to transfer their data. So with the decentralized storage or on-chain storage, I think you always have some pieces, right? And also, we can integrate some technology, which means that only I who own the private key or some kind of security can decrypt the data, which means that even if I put the data on your stuff, but it doesn't mean that you own it. And even you get my data, you cannot decrypt it because I'm the owner, right? So I think this is some scenario provide great value and unique value. And this is some features like come with the decentralized and the blockchain technology, which is centralized company doesn't want to provide, right? They have the technology, doesn't want because they want to have your data. So on the data protection, especially the coming days with AI, is very important. I give you another example because I'm currently using lots of AI tools. So like people using lots of Flutter or Copilot doing the coding, right? But one problem is that when you're doing the coding, you always put something like an access key. When you're doing crypto development, and probably have the private key. So who knows, like where they put the data? Maybe they upload your private key. It's not a maybe. I'm sure they scan your project, you scan your data, and save on their server. One day, maybe we will have some news say like, I'm sorry, we have an issue of a data leak. Now your data is open to the public or get stolen by others. So those all the domains, I think that they don't solve and they don't want to solve. So this is something like on-chain storage can help greatly about those critical data and the important data and ownership. Yeah, thank you.
Thanks, Charles. Yeah, data ownership is something that, it's definitely a hot topic at the moment. So, when we say like sovereignty over your data, it's an important thing. If I generate the data, I should own it. And one thing that that blockchain does very well, of course, is providing rails. So yeah, and providing ways for people to transparently and securely and verifiably give people access to that data. We had a great hackathon project recently where someone had set up a DAO. So the DAO has to vote on who can access data. So the agreement has to be decided within the DAO, and then a key can be issued. So definitely a great example there. Thank you, Charles. Okay, so let's move on. Talking about nodes now. What node roles do you have in your network? And how do user requirements shape these roles and their hardware and software requirements? Again, Chris, do you mind going first, please?
Yeah, sure. As I mentioned earlier, so our network is kind of split into many layers. At the base layer, we have our hardware nodes. So these are the guys that are providing all the kind of storage capacity or the compute capacity. And these are decentralized. So these nodes are individually provided by essentially anyone. We do have very strict performance quality thresholds so that not anyone with just a laptop can join. So we mostly onboard enterprise grade data centers. So these are the people that are, they have high quality hardware and they're looking to allocate that somewhere. And so you can be a node provider there, a node runner. So in this case, essentially, if you have hardware and it is of a certain quality that meets our threshold, you're able to run what we call a scalar node. And that scalar node essentially packages up a portion of that hardware. So you might want to portion it differently. For example, if you have a few hard disks, you might package them all together as one or maybe separately, but then you'd kind of then register that with the ICN protocol and say, I have 5 scalar nodes, each with around 500 terabytes of capacity, and I'm located in this region. Once you get registered and you're verified that's true, then now you're providing capacity to our system by running these scalar nodes. To do that, you also have to post some collateral. Obviously, being a decentralized system, we need to make sure that you as nodes won't run away, especially if we use you as data storage. Data gets stored by you. Some users that are using you would expect to see that tomorrow, and we use collateral to make sure that you're committed for a certain amount of time, and that you behave as expected. Secondarily, kind of, how do we guarantee that? How do we make sure that happens? So we have another role called the hypernodes, and these are the roles of guardians that monitor the hardware. So anyone can run this now. You can run this on a laptop. It's very lightweight, but their role is monitoring for faults in the system. Not just faults, but it makes sure that constantly, over a continuous timeline, that the performance guarantees of any scalar node meets the criteria. So at any point in time, there will be a record of the hypernodes having checked your scalar node. They would have submitted a report. This report gets then published on chain. And we have a separate network called the satellite network, where it essentially is a data availability network where you can see all the details about the report. So if you were to say, oh, I wonder what happened to these nodes in Germany, for example, you'd get a kind of timeline history of when it was up, when it was down, how much was used, how much wasn't, and if it was slashed because of misbehavior, you can see how it misbehaved and how much it got slashed. So it's important for us that, especially with a decentralized network, it's only really decentralized if it's verifiable and has to be verifiable in a transparent way. So yeah, we have the scalar nodes, which are the hardware. So you can become a hardware provider, provide hardware to our network and run that scalar node, and you'll earn rewards for doing so. Or you can run a hypernode, which is much more lightweight. The hardware requirements aren't as large, and your job there is essentially contributing to the security of our network.
Very cool. That sounds very elegant, Chris. So what you've done is you've separated the concerns so that you can have these different classes of network nodes, these network citizens. We do a similar thing. We have like farmers who are kind of pledging the storage and driving consensus, and then we have operator nodes responsible for execution, and they run on different kinds of hardware. Specifically for that, we don't want to. We want them to be able to be customized for the job. So, thank you, Chris. Really wonderful. Zeus, how about nodes on multiple network? What kind do you have?
Yeah, nodes are very core part of our network. We have almost 500,000 nodes right now globally. Most of them software. And that's why it's not that big of a hardware requirement. What we are essentially sharing is the bandwidth, right? So back to the how much upload and how much download bandwidth that each node is willing to share. And it's actually quite a lot. So say here in Hong Kong or in Singapore, very often, even a household computer has access to 2000 Mbps, like 2 Gbps, right? In terms of internet speed, and they typically are just using a fraction. So also very often, the ISPs, internet service providers, don't have a hard cap on the total amount of data transferred, unless it's really out of proportion. So that means they have a lot of idle resources, and through us, they can monetize it. So the role that they play, right? The role that they play is that because it's a large network that traditionally uses servers in an SD-WAN setting, the nodes are essentially replacing servers. So now we can choose which pathway to go through. Back to the sending something from, let's say, Hong Kong to San Francisco, the A to C example. And then we have to go through nodes B1, B2, B3, B4, B5. This is the most ideal scenario. But if that is really congested, a pathway, we can pick a separate path for them. And then if we remember the 30 different packets concept, there are many parallel kind of data highways, data pathways that they are going through. So that's that essentially is what the nodes are for. That being said, although the last two stages of our testnet has been pure software, we are now about to launch our hardware that will come at about the same time of TGE, and we're selling passes right now, NFT passes priced at about $200 to be announced in a week's time on our Twitter account. So what this essentially means, especially for the hardware side of things, is we have the very basic requirements down in a more stable setting versus a computer, right? So right now, if someone has to run a node 24/7, they have to switch on their computer naturally 24/7. But right now with the hardware, they can just plug it into their router and share it from their dedicated device while powering everything off. very basic requirements for the hardware, just quad-core 2 gigahertz each. That's for processing. We also have a bit of SSD, at least 100 gigabytes, although not much storage is needed, but temporary storage is actually needed. We're just going beyond what's needed to make sure that it's ultra stable. And that way, with the introduction of these hardware nodes, it's more reliable as well because it's a super dedicated node and we can funnel and channel more data through it. And the more data that goes through these nodes, whether it's software or hardware, the more points and tokens that our nodes or bandwidth providers will actually make.
That's very interesting too. So yeah, a kind of a different approach here. So for your network architecture to work, you need the huge number of nodes because they're going to be sending these packets off to each other. And I did see in your roadmap about the hardware. That's super interesting.
Right.
We talked about ASICs for autonomous consensus. So that is really interesting. I'd love to kind of hear about the challenges there. And I imagine that there are challenges with just trying to kind of scale the network. But I could see, a parallel if you look at like the Apple ecosystem where they control the hardware as well, opens up doors to being able to do a lot more things. You know how far you can push that hardware exactly. So that's really interesting. Okay, as a node runner myself, I'm picking up some ideas here, guys. But maybe there's some space on some boxes that I've got to run some more node software. Unfortunately, Charles has just dropped off. I do know that Swan they're kind of a little bit different in that they target bigger DC kind of infrastructure, but hopefully if Charles is able to reconnect, we can go back and ask him. Okay, we have talked on this one briefly, but let's get into it. So how do your respective networks ensure data availability and reliability in a decentralized environment? Particularly in the context of potential node failures or network disruptions, so people falling off the network, I guess mainly. So yeah, data availability, reliability, and resilience. Chris, how do you handle things like that?
Great question. Yeah, I mean, it's a hot topic, especially with data storage. You obviously need that to somehow be there. Otherwise, are you really storing data? The kind of approach we took actually is we saw it as a optionality. So data availability, if you're, let's say, too strongly wedded to the idea, from an infrastructure point of view, it means that you have to do replication by default. And when I think about it from ICN's perspective, where, okay, as internet infrastructure, do we really want to be replicating people's data all the time when it's not cost-free, right? What we try and do is, depending on the use case, users get to choose their level of data availability. Maybe users want to manage it themselves. Some users want to have local data. Maybe they don't want to store everything. Maybe they want to store one copy. Maybe they want to store several. But with us, we see data as it's a very abstract thing. And I think data availability normally is mostly to do with if you want to prove something somewhere else, and that event happened in a lightweight way. For example, when you think about L1 and L2 kind of things, how do you prove a state transition on L2 when you're only committing hashes on L1, right? You're not really committing everything. That's where the data availability comes in, because you need that in order to prove it. With us, we don't have a very specific vertical to do that. So really, if an L1 or L2 wanted to do something like this, they would be able to come on our system and configure, hey, I would like this level of data availability. Therefore, we give them more features out of the box. But it's something that we consider as more an optionality. And we think of data storage as a much more abstract thing. And so for us, it depends on the use case. We leave it as composable and as open as possible for applications and services to decide their level of replication, data availability. And the key thing for us is about data sovereignty.
Okay, so a focus on ownership, and I'm guessing you have like tiers, so you can say I want kind of these guarantees, or I'm comfortable at this level of replication and kind of accountability about my data always being available. Okay.
And so some people, maybe if you're storing really important data and maybe performance and reliability of it means more to you than necessarily the ownership and decentralization, you'll say, hey, I don't mind these objects stored replicated 3 times in 3 geolocations. But that kind of user is very different from other classes of users, and we want to make sure that we can capture the broadest range possible.
That makes sense, yeah. And replication is something that we do on autonomous. So we have erasure encoding and then kind of a replication, because all those farmers' plots are filled with replicated copies of the blockchain history. So just an interesting stat for you, because we've bootstrapped consensus in mainnet phase 1 and we're about to launch mainnet phase 2, we've got a replication factor of 4 million at the moment, which is kind of mind-boggling. I think we're 50,000 as well on testnet, which is equally as amazing. But yeah, thanks, Chris. Zeus, same question to you. So how do you ensure data availability and reliability?
Yeah, our touch on reliability, especially. So we use a technology called UDP UDT. Very often, one of the most frequently asked questions would be, hey, isn't it slightly less reliable than TCP/IP, although it's much faster? So that's a third technology that we use, by the way. But within an SD-WAN private network setting, through our software and our dashboard, you can actually monitor data packet losses. And the monitoring is more at the software level rather than at the human level. So in case there are any data packet losses, which there shouldn't be, you can resend it through another node, right? Or the preceding node doesn't delete that part of its packet yet, that fraction of its data packet. So that's one. And secondly, so computers might not always be on, right? Which is one of the reasons why we're introducing the hardware, as mentioned in the last question. So in a scenario where it's not always on, it has to be very dynamic. So that's the key thing that SD-WAN does. It monitors which nodes are live, which nodes have more bandwidth, and essentially in a macro setting, which is a more direct pathway, right? Best pathway. So it can compensate for nodes that are not around and then route it to another route. And that way, it increases its reliability. And the third thing in terms of reliability, right, is it also in a modular fashion. This part we use a bit of AI plus historical kind of analysis. We can actually predict which nodes in terms of their historical patterns are more reliable than others. And in a modular setting, rather than from a centralized software setting, they can actually make preparations. Okay, if this happens again, which pathways should we go through? And even though it seems like that's the best pathway, historically it has shown that if you go through, let's say, pathway F is much more efficient and faster than the originally calculated pathway. So that's all in all how we ensure reliability, making sure that it's received by the intended recipient.
That's very impressive. So if I understand correctly, you've got a few things going on there. So you're saying is that you kind of extended like the TCP IP stack to kind of handle your particular use case, which is like accelerating this data around through the peer-to-peer network.
UDP instead, yeah.
All right, yeah, UDP. So sending the message and broadcasting rather than kind of the back and forth. But and I just want to highlight, did I understand this correctly? So your network not only self-heals, so it identifies there's a problem and then works around it, but it also learns, so it knows that maybe Jim's kids come home from school and turn Netflix on, so maybe his bandwidth is going to
slower at 4 p.m.
Right. There's going to be lags, so don't route through Jim until they've gone to bed. Is that right? Am I understanding that?
Yeah, a bit of that, and also like the micro latencies as well, right? That take place. Maybe on a 10-second interval, although like Jim has set like a huge level of kind of contribution in terms of bandwidth. Some areas, some geographies are a bit less stable, so to speak, than others. Yeah, and also like you've highlighted a good kind of common scenario as well, where they might have other users of the home internet and slight fluctuations minute to minute.
Right. Okay. It's obviously you've gone deep on this. Some of this is new to me, so that's really interesting. Okay. So covered resilience and node failures. So specifically on bandwidth DePIN, I know that this is probably more Zeus's bag, but how can bandwidth DePIN benefit decentralized AI training, inference, and deployment? Chris, do you have thoughts there?
Honestly, not that much. Yeah, I mean, from our side, I think we think of networking as one of the resources that we want to enable in our kind of network of hardware. But the way that the hardware works is it will always kind of come with some level of networking bandwidth. So it's not as, let's say, our core focus as much as it maybe is for Zeus. So maybe I'll let Zeus take over.
Sure. Yeah, thank you for that. So usually I put it very simply in terms of performance, right? Overall performance, which we are concerned with, even on a retail kind of user level. When you want to buy, let's say you have a brand new computer that you're about to buy, you step into the shop. One of the first things that you might look at is processing speed, right? Do I want core or more? Do you want a general CPU? Do you want an CPU? So some of these things, first consideration. So that actually relates to more a bigger AI DePIN side of things, more of a GPU play that a lot of DePIN projects are in, which we're not. And then secondly, storage, right? Which Impossible Cloud is in. The second might be like, hey, how many terabytes or gigabytes do I want? Do I want SSD, etc.? You purchase that. And the third thing, bandwidth is really where we come in, right? You computer at home, and the next thing that you're thinking about is how fast do I want the computer to be or the internet to be, and then you try to, within your budget, purchase the fastest broadband connection possible. So if you kind of expand it, extrapolate this, and put it in an AI setting, the faster your data transfer speed is, the faster you can process it, essentially. So the faster you can train. And then the results are compounded, because very often you're training on your results as well. Very often AI companies are competing with each other. Back to the sports tech example, a typical AI company that's training on sports health data isn't the only one. And very often the edges might be very slight, let's say 2% faster, but then it gets compounded, right? Not just daily, but hourly as well. And the edge becomes very significant after. So that's why AI companies naturally find us super attractive, because we're solving a very traditional bottleneck of theirs. And then one thing to highlight is in the example that we've mentioned twice now is the third time, between Hong Kong and San Francisco, or just between continents, the undersea cables, usually an internet service provider, whether you're an AI company or just, let's say, me sending my wedding video to my friend across the pond, you have a very finite amount. I could buy 2000 Mbps. You can see your upload speed, right? It fluctuates. It just uses a fraction of the amount that you actually are supposed to be entitled to, because it's very finite. As long as your data is moving, your ISP isn't concerned with giving you the most or the fastest amount of data to squeeze through it. So in that setting, for AI companies, especially if they are pulling data from very far away, from sources that keep changing, we are especially useful, a technology like this.
Absolutely. I know that some of the figures, I've seen research, like when you're training AI models, I believe that I've seen figures of like the some of the write speeds when they're training, when they're using when they're processing the training data, and then they need to write out the weights, it's like 8 terabytes a second.
Right.
So if you're dealing with that kind of bandwidth, but then of course we want to harness, we want to do this over a network. That's the efficient way to do it, not just in, X's labs or Meta's labs. You know, we want everyone to be able to do this, and there's this unlock, isn't there, of being able to pump that amount of data around. And using training, you know, inference is still reasonably heavy, I guess, but yeah, that's really interesting, Zeus.
Thank you.
Okay, Charles, how are you doing? You're back. So yeah, hopefully we won't have a technical problem. So I'm going to let you pick what question you'd like to answer. So we've talked about the node roles on our networks. We've talked about ensuring data availability and reliability and like general resilience of DePIN networks. And we've also just been talking about bandwidth DePIN and how it can benefit AI. So I'm going to let you pick whichever of those questions you fancy answering.
Yeah, sorry about internet, but yes, all the questions are very interesting. So for us, like we say like we do working a lot on offering the computing power. What we found is that currently like it is the decentralized network is the best for the inference, because for inference networks you don't really need to care about the lots of stuff. For example, especially for those models, right, large language models, when you deploy it, right, you just need API calls. It's very similar to the decentralized RPC or other networks. It's not something like the training, right? Decentralized is really extremely hard. You already like the data. You probably like you need to have a large data set. You have a very big bandwidth required to transfer, right? When you add a data center, even though you add a data center, but you cannot guarantee the data owner is on the same network with you. For example, the AWS, if the data is the user is on the AWS, right? They want to transfer data to the DePIN network. It maybe cost him more than $10,000 to transfer like 100 terabytes of data, right? But on the inference, it's a totally different story, especially with the latest technology like RAG. You can submit a small data set, perform the inference system prompts or prompt engineering, and it become a network and give you lots of result, and pretty cool. The result, everything is pretty awesome. So so now we're thinking like at the current technology level, inference is the one makes more sense. And the storage, we still rely on the different storage network. In our network, we don't touch the storage part. Sounds like we honor all the people who is working on the storage solution. I'm sure they have the best solution for the scenario. So we only focus on the computing and the inference at the moment. In the future, maybe decentralized training. I don't know how long the technology side can be achieved. I saw like a lot of people put time and spend on that. For us, we do three things: high-end computer GPUs for inference, the challenge system, make sure like users, the providers who's online do the work, and also a compensation system, make sure when there's not enough jobs, we send small tasks to make sure it's most validated their status is really online or actually is already offline. We don't hold a large network like more than 100,000 nodes. We have a really small network with 1,000 nodes, but all the nodes who's running is capable of doing real work, because we're more interesting about it. And for us, like if the network is too large but don't have enough jobs, just like a country like don't have enough jobs but have lots of population, that become a heavy burden for us. So we are aiming at increase. Current utilization is around 40% of the GPUs. We're aiming like increase it from 40% to 80%. As soon as we reach 80%, we are like bring more deals to increase the total network size. Yeah, this is what we are working on, and so far so good.
That's really interesting. So I feel like we've almost got the two extremes there. So if we talk about multiple and Zeus, you know, and he's saying we got these, I'm guessing there'd be low power custom hardware, but lots and lots of them, as opposed to Charles, who's saying actually we don't need as many nodes, but they have to have enough grunt to get the job done, and it becomes like a task to make sure that the pipeline is nice and full for those guys to have something to crunch on and then use the the payment rails. Okay, thank you, Charles. Okay, last question, guys. So it's about interoperability. So how can we try and ensure interoperability between data DePINs? Are there any specific standards or protocols that your projects adhere to? Are you developing one of those standards in order to facilitate seamless integration with other platforms and applications? Chris.
Oh yeah, it's a great question. I mean, that's what we want to do, right? We don't want to create, again, a lot of siloed networks. It fragments it, and then I think the friction goes up. And I think ultimately we're trying to deliver use to end users. And the way we do it, I think, is actually, there's a lot of projects that are trying to do this. And we want to work with them. There's one on the top of my head that I can't remember, but I think it's the key thing, right? If we can work with projects that are already trying to solve this, and we can find standards instead of creating our own. I mean, you've probably seen the XKCD comic about competing standards. We don't want to create a new one. I think it's best that we work in our we specialize in what we do, but then work with the projects that already have a lot of focus on trying to unify a lot of this. I think we're starting with it with Impossible Cloud. We want to follow the current object storage paradigms. We are SV compatible. We have our own version of it, our own implementation. But the whole point is that we understand the industry operates a certain way. We do want to revolutionize it, but we also want to make sure that we're compatible with what other people are using. And we can apply that not just in the object storage world, but any other kind of service that we want to eventually try and replace when it comes to the known cloud services. Because ultimately we want to meet the internet and its services where they are, so people understand, okay, how do I run an EC2 instance? How can I deploy an app? How can I deploy a project? We don't want to change the way these workflows already work, but we also want to make our data and our compute and the resources we have available to other people, right? So we want to make sure that it's not just walled gardens where, again, we're all competing with each other. I think the only way Web3 is really going to reach adoption is if we all work together, and I think we have to try and be interoperable. And yeah, I think for us, we just try and remain as unopinionated as possible. We follow the market, and one of the things is we try to partner with as many people as possible, because I think partners is what dictates collectively what kind of standards should we use, what kind of formats should we use, and how can we interlink. That's kind of our way forward.
Yeah, absolutely, Chris. I feel the same. We don't want to be likened to kind of JavaScript frameworks of the 2010s, and together we're stronger. Great points. Zeus, interoperability in bandwidth DePIN.
Right. So when people talk about interoperability, right, very often they're talking about, say, conflicts between different Web3 projects that are native to different L1s. Hence, this Polkadot acting as L0, and then parachains coming out of it, right? But for DePIN projects, a lot of them are not Web3 heavy, at least not for OWLs. OWLs is essentially a Web2 technology. The only Web3 side of things is in the smart contracts that we have to calculate the rewards in terms of tokens to reward our bandwidth providers. So that's the Web3 component, the token itself and the rewarding mechanism, making sure that it's automated for the most part. So in that way, any AI company or any user for that matter, even if it's not AI, built on any type of chain, they can come to use our product. And kind of to explore that dimension in a non-Web3 way, can projects that are currently having different architectures, right, to send their data, incorporate our technology as well. So first off, they have quite a bit of incentives to do that, right, which makes them want to do that in the first place. So using our technology, it's about 12x faster than if they just use Dropbox, right, which essentially is send, store, and then send versus directly sending, which is us. So aiming towards that, how can they make sure that there are no conflicts? So one of the first levels of friction that we remove is that See, back to the AWS example, right? Since everyone's bashing them, very often you have a locked-in plan, or you have to choose which servers that you want to buy. And very often the fixed servers, real physical infrastructure in a specific place. So if it's a dynamic setting, you're moving things around, it becomes very tricky. On some months, you have huge amounts of data, and then maybe while you're working on the data, you don't need that much data transfer, but you have to pay the same subscription fee. So to make sure that it works, it's operable in all kind of contexts, month to month, we're only charging pay as you use type of model. So if they use more of our network in a particular month, they pay more, and if they use less, they pay less. So that really takes away a lot of burden for the companies. So to kind of summarize, no Web3 conflicts and a more plug and play, pay-per-use type of model that we use.
Right, plug and play and just works. I think, so I'll take faster internet if it's available.
Right.
Yeah. It just works with how I normally operate, how I browse. So maybe ultimate interoperability there, Zeus.
Right. Thank you.
Thank you, Zeus. Charles, same question. Are you working on any interoperability standards yourself? Do you adhere to any?
Honestly, like it's already like the no boundary, right? So any storage, any type of standard is working, but we still have some preferable way of integration. For example, there were two big category actually is the most favorable. One is S3 compatible, because like there's a lot of existing code, existing like applications they were building based on the S3 standard. So basically, like if you want to do bridging those use cases, use industry examples to your ecosystem, so S3 compatible is the best from Web 2. And on the Web 3, there's another thing, more like key store style, which is similar to the IPFS, right? So you can have a key values pair, which is you have a content ID, something like that. It's also another favorable thing. So those are the two most favorable protocols. A little similar to the current, like say in AI, people talking about MCP and those protocols. So we do have a favorite cases of protocol, even though there's nothing to block us to using any storage. It's just like a favorite way. I'm sure like lots of projects already like working on with those integrations. So if they don't have that, for example, last time we found like we're doing a small project, which is converting the IPFS become a bucket compatible storage. So we can use in bucket features and the story on IPFS. I'm sure like autonomous maybe already have the plan, already have the product, can do in the same way. Yeah, that's just some 2 cents from our past experience. We already stored over like 1 million objects. I shouldn't say objects because that is really like F3 conceptions of object storage, but it's more like a data, like a CID content. We also stored over 1 million with all the different content like transactions, tasks, right? Source of the, for example, source of the source code link, like Docker image link or GitHub link, something like that. We already have that a lot, so very interesting. So in the past years of experience, yeah, that's something from my side. Thank you.
Thanks, Charles. So I think you hit the big ones there. I mean, if you're going after existing users, then S3 is going to capture your traditional Web 2 users. IPFS, funny you should say that. It gives me an opportunity to explain it. Yeah, we have a product called AutoDrive, supports like IPFS CIDs, very similar content addressable, that data is stored in the farmer's plots, and MCP as well. I'm glad that came up because we've literally just added MCP to our autonomous agents framework. And with that plug, I know we're over time, guys, and thanks for staying on. But we are going to wrap up. I just want to give everyone a chance to share any info you've got for developers, entrepreneurs, community members who want to connect with you, build with you, or participate in any of your current or upcoming events and initiatives. Chris, do you want to go first as usual?
Thank you. Yes, we're actually close to launching our mainnet. We're aiming for Q2. We're going live with a mainnet alpha in actually a couple of weeks. And so the hypernodes that I mentioned earlier, these are our main guardians of our network. We're bootstrapping the security with kind of a setup for a ceremony phase first. So any of you guys that are out there want to start contributing to the security of Web3 enabled internet, please check us out, ICN. And then in late Q2, we'll be bringing on board all our hardware nodes, and that's when we'll be fully online. So we've got these 2 phases upcoming, so it's an exciting time for us.
Best of luck with the launch, Chris.
Thank you.
Thank you. Zeus, same question. How do people get involved with Multiple?
Yeah, so very similarly, we're listing on a tier 1 exchange this quarter. So what that means for people that have been contributing to bandwidth and for data transfer on Multiple network is they can exchange the points for tokens. And also for those that are tuning in that haven't been on board yet, you can go to multiple.cc, top right-hand corner, click on Get Started and download software. Over in this call, I also mentioned that you can look forward to our hardware that we're about to produce as well. And we are launching a limited number of 10,000 NFT passes. You need the NFT passes as kind of an ownership certificate almost in order to run a hardware node. And they're just going for $200. So that's the second way to participate. And if you have further questions or leave kind of few ways to reach out to me, if you want to reach out to me personally, usually the best way is to go to MTP_network. But just for those that are tuning into this call, start a new Twitter account, MBA for Masters in Business Administration _Oxford OXFORT, of course. You can drop me a line. Most likely I reply since not too many people message me over there. And the last way that you can actually kind of catch us excitingly in person is I'm flying to Dubai, just like many of us here. So Token 2049, Dubai. Polo is my favorite sport. I've been a polo athlete before. I took 1 year out of my career just to play polo. Been at some of the nicest polo clubs, especially in the UK. Guards for sure, Buckshire. So I'll be there at Crypto Polo Club as one of the sponsors, or at least a friend of one of the sponsors. And over there, it marks the start of the entire Token 2049. So see you in person, or let's catch up online.
Thanks you. So plenty to wish you luck for there. Hardware release, tier 1 listing, and polo matches.
Thank you.
Best of luck with all of those. Thanks you. Charles, same question. If people want to get involved with Swan Chain or anything interesting, exciting you've got just over the horizon?
Yeah, so we already have the chain launches. So if people want, they can directly go to our network. So using the inference, we also have a website called nebulablog.com, which is a very Web2 experience. If people like getting familiar with Web2 cloud, you can directly go there using the storage, using the computing power, inference, anything. However, it give you just a feeling like another AWS. And on the other side, it's like we are going to have an event in Consensus Toronto. So for people who are interested about the Consensus 2025 Toronto event, like come to us next month. We have 2 events. One is on 14th. It's a happy hour night. Another one is the Agent Summit Day on 15th. So, and we'll start open to speakers, sponsors, or even any projects want to be joining a happy hour with us. When I welcome.
Thanks, Charles. So I know that we have a few Canadians who are going to be in Toronto. It's their kind of their stomping ground. I see Zeus is giving us.
Yeah.
Maybe there's an opportunity.
We'll be happy to see you guys.
Okay, right. Just very quickly, Autonomous, find our website, autonomous.xyz. You can get all of our socials there. You can come and find me in Discord. I'm Jim Autonomous. And yeah, we have mainnet phase 2 just about to launch. Lots of exciting things going on. There's a campaign, Cosmic Cultivators campaign, just launched yesterday, where farmers can earn a chance to to earn some USDC, which is cool. Yeah, and with that, I just want to thank everyone. Thanks for joining me on the call today, guys. Super interesting to hear about all your projects. And yeah, thanks for bearing it out because we are over time. I apologize for that.
Yeah, thank you, Jim, for having all of us and having the storage, compute, and transfer part of AI DePIN all together.
Thank you so much. It's been fun.
Cheers, guys.